All right, everybody. So today we have geometric sequences is going to be our focus. So as I tell most of my students, although we just got done with all this arithmetic, you basically want to forget everything you know about arithmetic because geometric is similar realm, but obviously going to be slightly different because now we're going to be multiplying and dividing. So as far as a definition goes, what is a geometric sequence? It's going to be a sequence where each term is being multiplied, and technically you can also say divide it by some common value. And that number that you're multiplying or dividing by is called the common ratio, not ration, but common ratio. But again, technically we can say that we're dividing in some circumstances, but when you're actually identifying what R is, you're trying to identify what the ratio is. So a ratio, again, is really just a fraction. So I'll kind of give you guys an example as to what I mean by that. But how you're going to find R, again, this is the actual number that you're multiplying by. So to find R, because sometimes it's kind of hard to tell just by looking at a sequence. So what you want to do is take any term out of the sequence that you do know, and then you're going to be dividing it by its previous term. So whatever term comes right before it in the sequence, that's how you find R. So let me give you guys an example. Let's say over here, let's say that this is your sequence. You have 8, 4, 2, 1, 1/2, so on and so forth, right? So you can see what's happening in the sequence. You can see that you're dividing by 2, but if you had to actually identify what is R, we don't really want you guys to be writing something like this. Don't be saying that R equals divided by 2. Okay, again, R is going to be an actual ratio in this case. So not only are you dividing by 2, but technically, again, if you're actually solving for R, take any term out of the sequence, take like 2 for instance, divide it by its previous term, which would be 4, which is obviously 1/2. Okay, so if you're dividing by 2, it's the same thing as saying that you're multiplying by a half. But the more preferred answer, this is more so what we want to see. Okay, again, if you had to actually solve for R, you want to say that R is going to be a half, not that R equals divide by 2. So don't do that. Okay? So new formula for today. So to find any term in a geometric sequence, you're just going to take the first term, a sub 1, and then you're multiplying it by R raised to the n minus 1. Okay, so everything's all the same. A sub n is still the last term, or the term that we're trying to find. A sub 1 is still the first term. N is still going to be the number of terms, or a specific term number. And then the only new thing now is R, which is kind of acting like D was in the arithmetic sequences. Okay, so our first examples, it says to find the next 2 terms in each geometric sequence, and then also find the common ratio. Obviously, first figure out the pattern, so finding R. Again, if you can't tell by looking at it, just take any term, take like a -2, divide it by its previous term, which is -1, and R is obviously 2. So all we're doing is just doubling, we're multiplying each number by 2 each time. So after -4, if you times by 2, you'd have -8 times 2, -16. There's the next 2 terms. Now we're done. So same thing for the next one, figure out what R is first. So to find R, take any term, take like 3, divide it by its previous, which is 6. R comes out to be the ratio 1/2. We're just multiplying by a half each time. Again, if you're multiplying by a half, though, it's the same as just dividing by 2. So either way you look at it, it's the same thing. But if I multiply by a half the next one, so if I have 3 halves, and I'm multiplying it by a half, well, the next one would be 3/4. And now I'm taking 3/4, and I'm multiplying it by a half, so the next one would be 3/8. There's the next 2 terms. Okay, next one with decimals, again, sometimes not quite as obvious as to what R is, so take any term, take like 7.2, divide it by its previous term, so -2.4, and you should get -3 is R. So now you want to keep multiplying by -3, so the next one should be -21.6, and then timesing that by -3, you'd have positive 64.8 would be your answer. And the last one, number 4, so figure out what R is, take any term out of here, take like a 192, divide it by its previous, which is 480, and you get a fraction or a decimal, so just kind of depending how your teachers want it, either one would be acceptable. You could say 2/5 or 0.4, same thing either way. But now you want to keep multiplying by 2/5 or 0.4, so if you're doing the fraction, The next one would be 384 over 5. And the next one after that would be 768 over 25. But the decimals, so the equivalent decimals would be 76.8, and the next one would be 30.72. So depending again how your teachers want your answers, fractions or decimals. Okay? So now in our next section, directions say to find the first 5 terms of each geometric sequence that's being described. So we have the first term, and how we're getting to the next 4 is we're just going to keep multiplying that next term by 2. So 6 times 2, the next term should be 12, times 2 is 24, times 2 is 48, and then times 2 is 96. So there's the first 5 terms. The next one we have negative 27 to start. Now we just need to keep multiplying by 3. So the next one should be negative 81. Times 3 is negative 243. Times 3 is negative 729. And timesing by 3, you get negative 2187. 2187. Coming down to our next one, number 7. So we're starting with 240. And then we're timesing by negative 3/4 each time. So the next one should be negative 180. After that, it should be positive 135. Timesing by negative 3/4, you'd have negative 405 over 4, or the decimal is fine too. After that, it's going to be positive 1215 over 16, or again, the decimal equivalent would be fine as well. And the last one, number 8, so we're starting with 1/9, and then when I times that by 3, the next would be 3/9, which is just 1/3. If I times that by 3, I get 3 over 3, that's just 1, times 3 times 3. There's the first 5 terms. Okay, we're zipping right along here. These bottom examples, it says to find the indicated term of each geometric sequence. So again, how you read this, the first term is 5, we're multiplying by 2, and we want term number 6. So you could just start with 5, and then just keep multiplying by 2 until you get to the 6th term, because, I mean, I'm already pretty much already there. This would be the 6th term, because again, this is term 1, 2, 3, 4, 5, here's term 6, it's 160. But you can also use a formula too, which we probably need practice with anyway. So plugging this into the new formula, you're trying to find a sub 6, knowing the first term is 5. And then after that, you're multiplying by r, which is 2, raised to the n minus 1, which is 6 minus 1. So even if we work this out, it should still come out to be 160 either way. So working this out now, order of operations, I'm just going to change my exponent. That's just 2 to the 5th power. But again, order of operations, you want to do your exponent before you multiply. That's always a common mistake we see. A lot of people want to do 5 times 2, which is 10, and then raise 10 to the 5th power. Well, that's going to be way too big. Okay, 2 to the 5th power is what you want to do next, and that's 32. Now you want to multiply that by 5. So 5 times 32 is going to be exactly 160. Okay, so same thing for number 10. You can list it out if you want to, or use your special formula. So we're finding the 6th term again. First term being 18 times r, which is to the 6 minus 1. So we're doing 18 times 3 to the 5th power. So that's 18 times, I think that's 243. So now just multiplying 18 times 243, you should get 4,374. And there you go. All right, on to the next ones. Next page. What do these examples say? It says that you have to write an equation for the nth term of each geometric sequence. So again, we're trying to write an equation. Our answer itself is going to be an equation. Okay? So identify what you know. Just by looking at the sequence, what do we know by looking at it? Well, we can clearly see the first term, a sub 1. We could definitely figure out what r is. Looks like you're multiplying by 3, so r would also be 3. And that's all that we know. We do not know the last term, a sub n. We do not know how many terms are in the sequence. We only see 3 of them, but it goes on forever and ever past 27. Okay, so this is all that we know. So when you plug these 2 items into the formula, let me just write down the formula here. Again, these are the only 2 things we know, a sub 1 and r. That's it. We don't know a sub n, we don't know n. So when I plug those 2 in to find any term, we're doing a sub 1 times r, which is to the n minus 1. And you're done. That's it. Okay, so again, you can't actually simplify in this problem. You don't want to make this 9 to the n minus 1. You don't want to do that because that's not proper order of operations. You cannot multiply before you do an exponent. You can't do that. So this is incorrect This is all you got. You plug in a sub 1, you plug in r, now you're done. So same thing for number 12. We have a sub 1. It's obviously negative 1. You could figure out what r is. Looks like r is 3 again. We're just multiplying by 3 each time, so plugging those two items in to find any term, you're just doing negative 1 times 3 to the n minus 1. And there you go. Number 13. Once again, we have a sub 1. Let's see, finding r, let's do negative 24.2. I'm going to divide it by 11, but you should get negative 2.2. Okay, so negative 2.2 would be your r. So plugging those two items in to find any term again, you're doing 11 times negative 2.2 to the n minus 1. And there's your answer. The last one, 14, we have a sub 1. Figure out what r is for this problem. So again, taking any term, take like 350, divide it by 500. So that cancels. Divide these both down by 5. We're looking at 7/10, or you can use the decimal to 0.7. So either way, to find any term in this sequence, we're doing a sub 1 times r, which is raised to the n minus 1. And there's your answer. Okay, so really haven't spent a lot of time going through all of this because, well, we've been through most of this before, so it's all pretty much the same thing, just now we're multiplying. All right, geometric means now. So obviously just fill in those empty spaces, right? Figure out what are these numbers in between 5 and then 405. So we have to know what are we multiplying by. We have to try and solve for r. So we should have everything else then, which we do. We have a sub 1, we have a sub n, and there's 5 terms in this sequence. If you count it out, 1, 2, 3, 4, 5. Okay, so now solving for r, plug it into my new formula, and here's what we got. So 405 equals 5 times r to the 5 minus 1. Next thing, I'm just going to fix my exponent. That's obviously just 4. And now just think about how you get r by itself. First, you'd probably want to divide by 5. So getting r by itself, so that gives me 81. But now, if you recall, go back a couple chapters here, to solve this, you're going to take the fourth root. Fourth root, because it's r to the 4th power. So keep in mind too, if you take the fourth root, if you take an even root of two sides of an equation, you get positive and negative solutions. So I'm taking the fourth root of 81, which comes out to be positive and negative. Just to kind of recap, taking a fourth root, type in the index first, shrink it down, just like that. If you take the fourth root of 81, it comes out to be 3. So we're talking about positive and negative 3. Okay, so that's what we have to multiply by. We have to multiply each number by positive and also negative 3. Let me just show you guys how this kind of works out here. Okay, so let's just pretend that's just positive 3. We'll do the negative 3 part in just a second, but if you multiply by just positive 3, so if I do 5 times positive 3, that's 15. 15 times positive 3 is 45. 45 times positive 3 should be 135. So now what if I do negative 3? So if I just multiply everything through by negative 3, what do we get? Well, 5 times negative 3 is negative 15. Negative 15 times negative 3, well, negative times a negative is a positive, so that middle number, that middle term is basically going to be positive no matter what. Okay, it doesn't matter if r is positive 3 or negative 3, it's still going to be positive 45. But then 45 times negative 3 is negative 135. So basically what happens, if you want to write down your actual correct answer, your signs just kind of alternate. So filling in these blanks, let me just do it right above it. Basically, this first one could be positive or negative 15. But the middle one, like I said, is going to be positive regardless. It's positive 45. But this one's also going to be positive negative 135. So it just alternates. If you look at the signs here, you got positive here, plus and minus. Positive here, plus and minus. And then positive is what it ends with. So it's just alternating signs, basically. Okay, it'll make more sense and kind of come together and just be easier the more practice you get with these. Okay, so the next one, same idea. So we got a sub 1. Here's what we're ending with. And then obviously n, we have 4 terms altogether. So figure out r, find r. So you'd have 1/9 equals negative 24 times r, which is to the 4 minus 1. So 1/9 equals negative 24, that's r cubed. Dividing both sides by negative 24, or you can also say you're multiplying by Negative 1 over 24, same thing, but we're trying to cancel that out. So when you multiply, you get negative 1 over 216 equals r cubed. And now we want to take the cubic root. So if it's odd, you don't have to worry about that whole plus and minus thing. We're just taking the cubic root of negative 1 over 216. So just make sure when you type it in, cubic root, shrink it down. Okay, so now we have negative, don't forget the negative, fraction 1 over 216. And you should get negative 1/6. So r is just simply negative 1/6 is our answer. So now I just need to keep multiplying by negative 1/6. So the next one, if I have negative 24 times negative 1/6, that'd be positive 4. 4 times negative 1/6 would be negative 4 over 6. Well, that's just negative 2/3. And then if I multiply that by negative 1/6, I should get positive 1/9 after I reduce it. Okay, next one. So we got a sub 1. We have a sub n. And now n for this one is 4 again. So plugging this all in, you'd have 20.48 equals 5 times r to the 4 minus 1. So 20.48 equals 5. R would be cubed. Dividing both sides by 5 is not going to be too pretty, but you get 4.096. And this equals r cubed. And now you just want to take the cubic root of r. Cubic root of r cubed, cubic root of 4.096, you should get r comes out to 1.6. So now just keep multiplying by 1.6. So after 5, 5 times 1.6 should be 8. 8 times 1.6 should be 12.8. And just to double check, if you do 12.8 times 1.6, it should be 20.48. Okay, and the last one, geometric means, again, we have a sub 1, we have a sub n. And we have 1, 2, 3, 4, 5, 6, 7 terms. So there's 7 for n. So solving for r, 3/16 equals 12. R would be to the 7 minus 1. So 3/16 equals 12. R would be to the 6. Dividing both sides by 12, or multiplying by 1/12, same thing. You should get reduce comes to 1 over 64. Equals r to the 6, and now we just want to take the 6th root. So now that it's even again, you should get plus and minus answers, and if you take the 6th root, it should come out to be 1/2. So again, as far as the signs go, it's just going to alternate. We already have positive 12, so the next one is plus and minus. Next one's positive, after that's plus and minus, positive, plus and minus, ending with positive 3/16. So now just keep multiplying by 1/2, or dividing by 2, same thing. So 12 times 1/2, or 12 divided by 2 is 6, times 1/2 is 3, times 1/2 is 3/2, times 1/2 is 3/4, times 1/2 is 3/8, and then times that by 1/2, you leave off with 3/16. Okay, so pretty cool. Geometric means. This last one, little story problem. So we have a 110 ice sculpture. It's melting so that it loses 1/5 of its weight per every hour. So we want to know how much of the sculpture will be left after 5 hours. Write the answer in pounds. Okay, so 110 is what we're starting with. Well, we're talking about pounds here. So what is 110? 110 is 2,000 pounds. Okay, so we're starting with a 2,000 pound ice sculpture. So it's losing 1/5 of its weight every hour. And we have to know after 5 hours how much is left. So let's say 1 hour goes by. Okay, after 1 hour, if it's losing 1/5, what I'm going to do then, I want to know what's 1/5 of 2,000. So 1/5 of 2,000 should be 400. So again, if it's starting with 2,000, basically it's losing 400 pounds in that first hour. So 2,000 minus 400, right now I'm at 1,600 pounds. Okay, now second hour goes by, so now 2 hours. Now I have to figure out, well, what's 1/5 of what's remaining, which is 1,600 pounds. So if I do that, it should come out to be 320. So now I have to subtract 320 from the 1,600 pounds. So if I do that subtraction, it should be 1,280 pounds. Okay, now 3 hours. So now we're on to hour 3. So now what's 1/5 of 1,280? So that comes out to 256. So if I subtract that from 1,280, now we're at 1,024 pounds. So almost half of what we started with, right? We started with 2,000. So after only 3 hours, it's already melting down to half of its weight. So now, next hour, 4 hours. So I want to find what's 1/5 of 1024. So that should come out to 204.8. So now subtracting that from 1024, now we're at 819.2 pounds. Now for the last one, so 5 hours to the last one. What we're doing is again 1/5 of where we're at right now, which is 819.2, and that should come out to be 163.84. So if you subtract that away from 819.2, you should get 655 pounds, or 655.36 pounds will be your final solution. So starting with 2,000 pounds, it shrunk all the way down to 655.36 pounds. Okay, so there you go. There's your lesson for today, geometric sequences. Let us know if you have any questions as usual. Otherwise, have a great day.